So I tried converting a computer power supply head lying around into a bench power supply used for electronics and such. Unfortunately, it did not work out because I suck at engineering, despite the fact that I have an engineering degree. Kind of a bro moment, not gonna lie. The reason why I had this computer power supply line in the first place is that a couple of years ago, I upgraded my old computer's graphics card from a GTX 1050 to a GTX 1060 that a buddy of mine had lying around. Unfortunately, that computer's pre-installed power supply did not have additional cables to supply the graphics card, but luckily another friend had a modular power supply that he was willing to let go, and we swapped that with this new one. Rather than have the power supply's life be wasted as a glorified paperweight on my desk, I wanted to do something with it and create a power supply for my electronics. The voltage output for this thing is mostly 3.3 volts and 5 volts, which is super useful in electronics as that is the most common voltages used. There are also a couple 12 volt lines, which is a nice bonus for a bunch of different things such as amplifiers. Since there are two 12 volt lines, I wanted to see if I could make one of them be variable rather than fixed. I did not have a chance to take power electronics classes at university, so I don't know if chaining different power supplies together, in this case a buck converter, would be a good idea or not. So, I guess we'll find out in this project if it works or not. Each of the 12 volt lines can do over 10 amps, which is kind of nutty, but I don't see myself using over 240 watts of power at the same time. Maybe if I'm using some kind of amplifier for a motor project, but I don't see it. The 3.3 volt line and the 5 volt line can also do over 10 amps, but together they are limited to 100 watts, which is fine as I said, I am not planning to utilize that much current. So the main idea is to redirect the power wires from the Molex connectors to our custom connectors, the banana connectors that are used for electronics. If we open up the power supply, we see that there are an additional amount of wires. Voltage standby, which is always on and as seen on the side label gives 5 volts. We can use this to power some basic logic circuits like LEDs and such. Voltage power good, which is always on if the power supply is working correctly. We can use this as a signifier to say, hey, the thing's not cooked. And then we have VRAM, which I have no clue what it stands for, but it controls if the power supply is on or off. The supply turns on if this wire is shorted to ground and off if we leave it be at its default high voltage state. In order to add the enable indicator, we can put a small PNP transistor in order to have an LED turn on when we short VRAM. To make one of the 12 volt rails variable, I bought this buck converter from Amazon that changes its output depending on the resistance of this potentiometer. The plan is to desolder the potentiometer and replace it with wires that will lead to my own potentiometer that we can actually adjust. We can use these two screws on the power supply casing itself in order to attach something to it, specifically a component I like to call the electronic board, as it holds the wires and the resistors and the buck converter and some other attachment points to screw the various components. The front will have a bunch of banana connectors with voltmeters and ammeters that I found on Amazon. The front panel will also have a switch to turn on and turn off the power supply with two LEDs showing the power good state and the state of the system, the health. The potentiometer will also be mounted on the front in order to control the buck converter. To hide all of the wires coming out of the power supply, I thought of using magnets to attach the side cover to it without having to resort to using screws, which, it makes it look fancy and such. I first printed the electronic backboard, which I named the E-wall to install the power resistors and the various wires for power. The reason why we need these power resistors is to stabilize the power supply's output voltage. The quick explanation is that if we boil down the power supply to this simple circuit, the voltage output is stabilized by this inductor, which in itself depends on a constant change in current. But if this is left open, no current is passed, thus no change in current, thus no stabilizing effect. Once I decided to start soldering things up, in this case the banana plugs, I decided with all my genius thoughts to heat up this metallic part of the banana plug, not knowing that it connects directly to the plastic. And do you know what happens when you heat up something with plastic nearby? Oh wow, the plastic melts. Oh, I melted the plastic. The metal part that connects the actual plug came out. And this is where things started to go awry. Luckily for me, these connectors fit perfectly to the banana connectors, which in all honesty I think is what is supposed to be done, but oh well. I spent the next few hours stripping wires and crimping to protect the actual metal part from shorting. I put a bunch of heat shrink as well. I do not have a hot air gun blower thing, hot air gun, so I used this technique that I picked up from a guy from Uzbekistan that I met a few years ago at my university. Basically, you just use the hot part of the soldering iron that's not dirty to heat up the heat shrink and make it go shrink. Deferring the idea of how to mount these LEDs to a future version of me also proved to be a suboptimal decision. Having these holes be too large, I resorted to hot glue, which, was okay. To hopefully fix my previous mistake of heating up the banana plug directly, the super glue you see here is a Hail Mary to secure the metal part to the actual plastic. I soldered a T-connection between each of the pairs of the banana cables. Some of these soldering jobs is pretty bad and I hid them with heat shrink, thankfully. The USB connectors were also pretty bad. The wires were incredibly small and really painful to solder. Since I also deferred the mechanical decision on how to mount them, I went with hot glue as another Hail Mary approach. After soldering the front plate to the fuses, it was time to do a first dry fit of the build. As you can see, my fellow friend, there's no way that it can fit. The back plate takes up a whole centimeter. I would have to take the whole E-wall out if I want this thing to fit. But then I thought, what if we allow the power supply to take up this 1 centimeter space? I printed a new bracket so that we have a whole centimeter to work with while still keeping the E-wall secured in place. Finally, it was time to connect everything. With my infinite experience and wisdom that I have demonstrated throughout this project, I decided to say, hey, let's actually test the power supply itself to see if it actually turns on. And guess what? It did not. While debugging the thing, I noticed for a split second that the buck converter's LED would actually turn on. I hope that that's meant that the device itself was not cooked. Perhaps some protection circuit against short-circuiting was tripped, which means I was saved by actual professional engineers. Bless their souls.
Okay. Well, there's an issue. The power lines are grounded.
The issue was that I soldered a 5-volt wire to ground. But you know why? Because the color of the wire was black. Black as in ground. Why would they color the wire black if it wasn't ground? So after snipping that wire, everything worked. Thank God, nothing was dead. After some struggling with the potentiometer that came with the buck converter, you can see that hey, it actually works. It changes the output voltage, which was very cool. Time was for the final assembly. It did not look good. It looks like a patient with the guts strewn all over the ground. After spending more time than I would like to admit being confused what wire was what, most of the wires seemed to be connected to the power supply. When I did short VREM to ground to enable the power supply, the whole supply flickered as seen by its built-in LED. The final turn-on showed that the RAM light was on. The first instinct is to be happy, but the LED being on when the supply should have been off was not a good sign. Testing the voltage at the banana jack showed only 3 out of the 4 having voltage. The variable voltage supply was also messed up, which I have no clue since I measured that the potentiometer should be exactly the same as the one that came with it. At this point, it was, in my opinion, impossible to finish the project without restarting the thing. Every decision that I deferred to a later date came back to bite me and screw me over. Even if I did somehow solve the electrical issues I faced, the nest of wires in this closed space with no proper split and organization kind of freaks me out. I do not trust this thing to not short out. Despite this, I actually do want to finish the project. It seems super cool and it's not that hard on a theoretical level. Luckily, next time when I do this project, I will know the issues that I will face mechanically, and hopefully I will be able to not be lazy and actually think about how to solve them before I build the thing. Thanks for watching, my friends. Have a good day.